In this lecture, we will take a look at some fair machine learning practices. Here's our lesson objective. Okay, so the first approach is pre-processing, and this deals with transforming the underlying data to remove discrimination. In other lectures, we took a really close look at bias in the data and what could be the possible sources of that. And so in cases where we were actually able to modify that data, pre-processing techniques can allow us to remove that discrimination or that bias. This can include things like rebalancing the data or removing certain features that might be the source of indirect discrimination. In processing, now this is involving changes to the algorithm. So in cases where you can't go and attack the data, or in cases where the algorithm itself is causing the bias, we have to consider what we need to do to the algorithm. Now, to think about this in terms of two cases is one, you have cases where you maybe can't do something to the data, so you have to think creatively of how to overcome that. And two, are cases where maybe the algorithm itself is creating the bias. And this likely isn't going to be because there's anything inherently bad or discriminatory about the algorithm. It'll actually likely be that the default settings aren't appropriate for your particular use case and end up overemphasizing things that create a bias. And so being conscious of this is, well, what can you modify? Well, there's like the objective function or the loss function. There are, many solutions allow you to add different kind of constraints. Or how are you regularizing things? And these are great places where there's a lot of hyperparameters, as we've seen in other lectures, and everything from deep neural nets to linear regression to random forest and gradient boosted decision trees. All of these have a slew of hyperparameters and different kinds of functions and stuff that can be changed and experimented with, and we can look at is this being effective in making our system more fair. So finally, there's a third approach called post-processing, and this deals with after the training is done, you have a holdout set which was not involved in the training of the model. And the idea is you want to be able to now reassign labels that were assigned in an unfair manner. And so this is adding an additional split to your data set and an additional step in your process. This is likely the most difficult way to do business because you're now adding essentially an extra model and you're further dividing your data set up. But this also can be a way that you could treat everything before it as kind of a black box, and you could be more confident that it's doing something to make the system more fair. And you can actually, this could actually be demonstrably shown to do so. And yeah, of course, this is useful in cases where the data and algorithm cannot be modified. So fairness testing. So the key really with anything is to be further evaluating your system even after it's been trained, validated, and tested, because there's other things to watch out for. And in other lectures, we'll discuss this more. One of the big things, of course, is fairness and bias. And so the nice thing is a lot of the fairness criteria is really based on looking at true positive, true negative, and false negative numbers, but with respect to different subgroups in your data. So these are all things that are pretty easy to calculate. And there actually is a nice open source tool called AI Fairness 360, and it's curated by IBM. And it's got many of the fairness methods implemented in both Python and R. So anyway, this concludes our lecture on fair practices for machine learning. Stay tuned for more content.